All right. Well, let's get looking at Unit 2. We got some compound structures and properties. So we start off by looking simply at types of chemical bonds. This should be a little review from before. You've got some ionic bonding, covalent bonding, and metallic bonding. Bonds happen to have this lower potential energy. When something forms a bond, it is generally at a lower energy than it was before. And it's really a spectrum. You'll find out values of electronegativity that'll say, oh, this below electronegativity will be ionic and this one will be covalent. It's really just a blend of things. A very simple way to look at things is when you have a metal and nonmetal ionic, two nonmetals covalent, metal and metal metallic, and kind of what's going on with their electrons. So get used to that, get used to using those terms properly as it's the general basis of types of chemical bonding. Even though the bonding may differ, the lowest energy is attained by stable electron configuration, and they do this in different ways. Nonmetals share valence electrons, which we'll get into in the second half of this unit. The metal atoms kind of share entirely, where their iron cores, which are positive nuclei, will be centered in each. That's why metals are often solids. And then in ionic, metals lose valence electrons to become an ion, nonmetals gain. Those are going to make those stable. Then the ions themselves attract one bond. Often the discussion is, does a metal ion give up an electron and then the other one takes it? That's not what occurs. The idea is that when we come across things in chemistry, you're going to have a lot of ions that have already been formed. They're stable. They're just in other compounds. And then they just switch places. For example, like silver nitrate and sodium chloride. Both have stable ions in their stable form. However, they're both soluble in water. You put them together and you get silver chloride, which is insoluble as a solid, and those ions attract. So no electrons are exchanged or anything else. The idea is that what was attracted to opposite charged ions, they're now attracted to new ions. So they're stable because of their electron configuration. So you might remember electronegativity, and that this decreases as you move away from fluorine, kind of step down function as you go to francium. This is usually used to determine the bond between the two species. So when you have a big difference in electronegativity from something like oxygen and chromium, that big difference will result in an ionic bond. Small differences are often covalent. Metallic really doesn't involve electronegativity because of the fact that these aren't taking electrons away from other atoms. This explains Coulomb's law, why smaller atoms have a higher electronegativity. Because you have a smaller radius, that means your force is going to be exponentially increased because it's in the denominator. So you might want to keep that in mind as you're thinking about electronegativity. Now, when we look at just how the bond representations are often formed or shown, we have some things like covalent bonds are shown with angles and lengths. So these are shown in more detail. You might remember these from being like structural formulas or Lewis dot structures. These will help determine physical and to some extent chemical properties. We'll get into that deeper throughout this course. However, when we think of something being polar, meaning it has a positive and a negative side, that's because of their difference in electronegativity. So these are the scales I was kind of talking about, to where it's pretty generic. You'll look in different books and find a different range that's going to vary slightly. Really, if you have the same elements, they're going to be 0, and maybe a small difference like between carbon and hydrogen is a carbon one. And then you have the intermediate, your H and your Cl and that kind of stuff. And then ionic is going to be quite large. Again, you think of your nonpolar bond, they're sharing equally or mostly equally. Very unequal is where you're going to be your polar covalent bond, and then ionic are very different. You see that they formed with ions. These are atoms with their overlapping abilities. Now, when you have a molecular compound, there's this idea that the strong bonds are what makes each molecule. Intermolecular forces are between the molecules. We'll get to that in Unit 3. So intermolecular separate the idea of something being solid, liquid, or gas, while the actual molecule is developed by bonds alone. Hope you enjoyed that in-depth, or I shouldn't say in-depth, cursory look at bonding. That should be really starting to refresh in your brain from things from earlier chem classes. Let me know what questions you got. I'm here to help. Take care.